This is the rest of the notes for 3, where we're going to be solving quadratic equation. And to means quadratic equation looks like ax squared plus bx plus c, and it's going to be equaling 0. So we're in search of those x values that have an output of 0. In order to solve a quadratic equation by finding square roots, and I actually sometimes, instead of calling it that, I call it, algebraically. Just using straight algebra, algebraically. What that means is here, I'm going to show you on a blank sheet of paper here before I give you the steps for it, because I think that'll make a little bit more sense. So when you have a quadratic equation that looks like, say this, 2x squared plus 5x plus 3 equals 0, the algebra attack for solving for x is to do the opposite, or the inverse operation. So when you were in pre-algebra and you were solving something like this, you'd say, well, to get x by itself, I just need to subtract 3. Or even if you had, say, 2x plus 1 equals x minus 4, you could get those x's combined on one side of the equation, and you could solve for x. Your problem with the quadratic equation is no matter how hard you try, you can't get these x's together, because this is an x squared term and this is an x term. So they're not like terms, which means I can't solve this one algebraically. But if I eliminate and don't have a b term, it's the x squared and the x that cause us to have a problem algebraically. However, if I had something like this, 2x squared minus 1 equals, say, let's make it equal to 7. Now, this is a quadratic, because it's to the second degree. I can solve this with just my algebra inverse operations, because I can attack that x. I can get the 1 out of the way by adding it, and get 2x squared equals 8. I can get the 2 out of the way by subtracting it, and get x squared equals 4. And the inverse operation for squaring is to square root. And so I can attack this one with algebra because I can isolate x. Whereas up here I can't, because I've got an x squared and an x term and they don't combine. So in our notes here, where was I? Sorry, I'm back a page. Where it says equation must be able to be written as, it must be able to be written as x squared equals some number. What that means is you must be able to isolate x squared on one side. Furthermore, what that really means is there's no b term, or you might think b is 0. They look like ax squared plus just c. There's no b term, and it allows us to attack that x with just pure algebra. Because what we end up doing to undo squaring, we take a square root. So here's the deal though. This is really important, because what this is saying is if you end up having x squared equals 9, so you do the inverse operation and you say x is equal to the square root of 9, and you say x is 3. It is true that 3 squared is equal to 9, but actually negative 3 times negative 3 is also 9. So there's two solutions to this, and we write that as plus or minus, plus or minus. When I square 3, I get a 9. When I square negative 3, I also get a 9. So we're going to be getting two solutions to most of these. So let's go solve this. We can use this method on this one, but it's important that you understand why, because we're going to have multiple methods for solving. Today we're doing the square root method, which means I'm going to be able to attack x by getting x squared alone and then taking a square root. And again, what that means furthermore is that there is no b term in here. You'll notice it's 3x squared minus 75. There's no just plain x term. So what that allows me to do is isolate that x squared by doing inverse operations. I add 75 to both sides. Now I'll get 3x squared is equal to 75. The inverse of multiplying by 3 is to divide by 3, so I divide both sides by 3. I get x squared is equal to 25. And when I take the inverse operation, the inverse of squaring is to square root. What that means is if I take the square root of both sides, the square root of x squared is x. Watch it with the number. The square root of 7 squared is the square root of 49, which is just 7. So these two operations cancel each other out, and we say that the square root of x squared is simply x. All right, and on the right-hand side, we get plus or minus the square root of 25. Make sure you include that. And it's important to know, I didn't bring my graphing calculator up on this one, but I'd like you to know that had you graphed this one, its related parabolic function or quadratic function is y equals 3x squared minus 75. So remember we said that the vertex for those is at 0, and then whatever you get when you plug 0 in, which in this case would be 0, negative 75. So it's way down the y-axis. There's a vertex. But if I graphed it on my graphing calculator, what I would see is that parabola opens up because it leads in a positive, but it's going to hit that x-axis at negative 5 and 5. Both of those cause a 0 to come out. And again, let's look at algebraically why. If I put a 5 in here and square it, I get 25 times 3 is 75 minus 75 is 0. So this is a viable solution. When I put the 5 in, a 0 comes out for y. Also, though, that's the important of remembering that plus or minus because you're missing a whole valid solution if you forget to put that on there. Watch. When I put negative 5 in and square it, negative 5 times negative 5 is 25. Multiply it by 3, I get 75. Minus 75 is 0. So this is also a solution over here. So although we're not doing them graphically, it's important to understand that when you get your answers, you're really finding the x-intercepts on the graph. All right, so let's go look at number 2 here. I can attack this one with pure algebra because I don't have a term with just m in it. I can move the 36 over, and again, my attack is on m. I'm going to isolate it or get it by itself. So I've got the 36 out of there. To undo a square, I square root. When I square root m squared, I get m. And then I go plus or minus the square root of 36. Don't forget that, or you're missing a whole part of the graph. And what I get is plus or minus 6. What that means is that if I went and graphed that one on my graphing calculator, it would hit at negative 6, and it would hit at positive 6, 0, and that one opens up, vertex is 0, negative 30, so it'll go way down to negative 36. Let's go look at B. I get 3x, and all the work here. I would subtract 15, 3x squared is equal to negative 15, divide by 3, divide by 3, I get x squared is equal to negative 5. Now right here, when I take the square root of both sides, you can't square root negative numbers. This is not a valid operation because there's no number that when you multiply it by itself, you get a negative. So what that means is this has no solutions. I can't do it. Now, I could have actually seen that up from the get-go if I used some common sense. Because remember, whatever I put in, I have to square it. And when you square numbers, they're always positive. When I triple it, it's another bigger positive number. And then when I add 15 to it, it's really positive. There's no way I can put a number in for x and get 0 out. It's just not going to happen. If I were to have graphed that one on my graphing calculator, its vertex would have been at 0, 15, and it opens up because of the 3, and graphically it would have completely missed that x-axis. So it's possible that we get no solutions as well, so keep your eye out for that. We can't root negatives. Watch the next one. I'm going to attack that d by getting the 16 out by subtracting it. I get 4d squared is equal to 0. I divide by 4. I get d squared is equal to 0. Which means d is equal to the square root of 0, technically plus or minus, but plus or minus 0 is still 0. So this one has one solution. So again, it's possible to have two solutions, like on letter A, which means the parabola hits twice. It's possible to have no solutions, like on letter B, which means the parabola never hits the x-axis. It's possible to have one solution, like on letter C. And what does that mean? That means that the parabola actually hits the x-axis at its vertex. So on this one it'd be 0, 0 if you were to go graph it on your graphing calculator. So keep your eye out for one solution, two solutions, or no solutions. So it says summarize the two methods you've learned for finding the solutions. I first showed you how to do it by looking at a graph. At the graph of y equals whatever your function might be. And remember, when we look at the graph and we want the solutions, we want to know where y is 0. That translated on the graph to those x-intercepts. We don't choose to do it graphically because it's kind of inaccurate. If your solutions are at decimals and that kind of thing, it's just not the best method. It's great for seeing what you're doing, but it's not a good method to actually do by hand. In part 2, we did it by isolating x squared and taking square roots. This is great, but the problem with it is, and the reason we have to teach you more methods, is what we'll explain down here. It says, what are the advantages and disadvantages? The graphing, its biggest advantage is it gives you a great visual for what you're doing. You wouldn't forget to put 2 answers if there's 2 because you would see it hitting twice. And you can actually see where those solutions are. So it gives you a really great visual. The problem with it is it's really not very accurate if that parabola doesn't hit at a nice spot. You might wonder what I mean by that. Had this been between 1 and 2, you really don't know yet whether that's at like 1.4 or maybe it's 1.43 or 1.61. If it doesn't have a direct hit at a whole number, graphing fails you because it's really hard to guess at where that is. And so let's take a look at our other one. For the square root method, its greatest advantage is honestly, it is easy. You just use your pre-algebra skills of isolating a variable by if there's addition, you subtract, if there's subtraction, you add. The only thing we did is add to it that if there's a squaring, you square root. But the square root method is really nice and easy. It's also very accurate. So why is it not my favorite? Remember what we said at the very beginning. This only works if you can isolate x squared so that you can take the square root. You can only isolate x squared if you don't have that b term in there. So although it's a great method and it's really easy and really accurate to use and you're going to cruise through your homework, it doesn't always work. Or we'd say it doesn't work for all quadratic functions because the minute I throw a b term in there and make it x squared plus 8x plus 15 equals 0, I can't isolate that x squared because this 8x is in the way and it doesn't combine with it. You might say, well, I'm going to subtract 15. Well, great. You'd also have a true statement, but then what are you going to do to get at that x? So although square root method for today is easy and it is accurate, it doesn't always work. So that's what our next sections are going to be on, is how do we attack a situation like this where we do have a b term. So to wrap things up, let's just do one last problem. Suppose it says to solve 3x squared minus 1 is equal to 47. Can I attack this by using square roots? Yes, I can. I can get rid of the minus 1, I can get rid of the 3, and I can get rid of the squaring, and I can attack x just with pure algebra. Remember why, though? There's no b term there. So I add 1. I get 3x squared is equal to 48. I get the 3 out of there by dividing both sides by 3. I say x squared is equal to 16. To undo a square, I take the square root. The square root of x squared is x, and then we say that that's plus or minus the square root of 16. You're going to forget that. If it were on a graph, you wouldn't forget it because you would see it hitting at 4, but you would also see it hitting the x-axis at -4. So that's the end, and your assignment is listed on the front page of your packet. Have a great day.